torpedoes, mines. I showed you one of those examples before. There's one up there. They're actually testing that ship to underwater explosion. And weapons above the water, missiles with various types of warheads. Very, very challenging warheads to defeat. And so that's what goes on in the survivability area. They might also deal with fire there. Materials of all types and fabrication of materials, like different welding techniques, procedures, welding materials, composites, ferrous materials, aluminum. Structures area, talking about the hull, deck house, if you will. Different types of materials for those structures. Heavily into computational analysis, computational methods to evaluate those structures, and worrying about the environment on the ship and in the ocean. Years ago, we could throw anything we wanted overboard. We could throw bilge water over there. Can't do that anymore. No solid waste. You can't throw those plastics overboard anymore. So you got to deal with them on the ship. If you got an aircraft carrier at 5,000 people, that's a lot of stuff. And so you got to find ways to deal with that stuff. And one way they found for dealing with plastics is to take it, heat it, compress it, so you get these discs about 12, 14 inches in diameter, about that thick, and you store it that way instead of plastic bags all over the place. And so, and then we're also got to deal with the liquid waste before they expel it. So that's kind of what goes on in the survivability structures and materials department. Again, these are backups. I'm not going to go into. Look at these at your leisure. Marine corrosion is a very important problem they deal with. Composites is very prominent. Oh, I want to show you this because it's very interesting. Submarine, North Pole. U.S. many years ago wanted to know whether, if they had to, they could surface at the North Pole. Okay, and so prior to doing that, they actually did some model tests up at the Cold Regions, the Army's Cold Regions Laboratory in New Hampshire, not too far from Dartmouth University, with models. So we were surfacing models. They could grow a sheet of ice in this tank, and we could surface the model, measure the loads on the sail. That's the sail and the control surfaces, diving planes that you see exposed. And so following those tests, decided to go ahead, instrument it, go up to the North Pole. We actually had a team from the Carter Rock Division with these other folks that went up there and participated in that exercise, which they called ICEX. So very interesting piece of work. Now this is the weapons effect stuff. Okay, major facilities. For this department, I'm going to skip to the next one, which shows you a little better. But there's a list of the major ones, including one up at Philadelphia. But here's a blow-up of a couple of them. They have a pressure tank complex as part of their structural evaluation lab. The purpose of this is to subject these structures, primarily submarine or submersible structures, to the effects of hydrostatic pressure. Here they're testing a pressure vessel in a spherical tank that could go up to 10,000 psi. They have another tank that's 30 foot in depth, goes into the ground 30 feet. They go up to 3,000 psi to test the cylindrical model of a submarine, if you will. They want to know how the submarine is likely to collapse and at what pressure level the submarine is going to collapse. So combined with the experiment, they'll do the analysis, again with very high power computational methods to understand the behavior of the submarine. Then they'll go out on a deep dive with the submarine, a trial, do the instrumentation, something I wanted to do in my career I never got to do, and that's probably the only disappointment I've had. It just seems so exciting to do that. However, there are some, when you see some water coming in through the hull, drips of water, you wonder whether that was the right choice to join them on that deep dive. But anyway, so they do that also. This is a full-scale propeller. This is the propeller design that went on the LPD-17, the San Antonio class that I previously showed you. being tested in a structural evaluation lab. This is a separate building from where these pressure tanks are, to over 2 million cycles of fatigue type loading. When these blades get loaded with, as they go through the water, it's a fatigue type loading. They're loaded, they're unloaded, they're loaded, they're unloaded as they sweep through the water. They were having problems where they connected the bolts that connected it to the hub. And so they went through this cycle of tests in that laboratory. Very interesting. And this is another facility at the Corrado site, part of the structures survivability and materials department. There's an explosive pond where they could test up to about 1 pound of TNT equivalent, if you will. Very good clarity, so they could take movies of what's going on. They want to see how the pressure loading from the explosive interacts with the hull. There's a lot of things that go on. There's the first shock loading, then bubbles form and collapse on the hull. And so they're able to do that in a very controlled environment at the Corrado site. And I think the next one is the signatures, folks. Okay, so this is the signatures department at Corrado. Again, their goal in life is to make our systems quieter, less observable. What was that?
Look smaller.
Yeah, look smaller, yeah, less observable, radar, talking about radar cross-section, if you will, than the other guys are able to detect. Again, remember, that's why we need to know the other guy's capabilities. That's why you have to have your foot in the intelligence community, because you don't want to make these things quieter or smaller than they have to be, because that costs money, okay? And it's always a cat and mouse game. You do something, then the other guy does something. You do something, you know. So that's their goal in life. They're full spectrum also, if you will, from cradle to grave. These are the kinds of products and services they get involved with. From mitigating signatures, if you will, again, whether it be acoustic or radar cross-section or electro-optic or infrared. Here's an example where they were trying to acoustically silence machinery system on the DDG-1000. So they basically acoustically isolated it on the raft. That also works on submarines. So the energy from the machinery is not going into the water to send out a signal, if you will. Let's see what else is shown here. They have some systems, particularly in the radar cross-section area, that are mobile, so that they can take that out there and actually measure a real ship. They also have a facility up in Ketchikan, Alaska, where they could take an operational submarine, make it neutrally buoyant, and then turn all the systems off, and then turn them on one by one, the machinery systems, and see what the noise spectrum is for those. And so that's a very powerful facility. And these folks on here are familiar with the facility out in Idaho. Very deep, quiet lake where they have quarter scale models, both surface ship and submarine, where they could do various types of testing to check either flow noise or radar cross section. Very, very nice facility. And nice part of the country, I might add. So they also do, I guess I said that, the requirements definition. What is really required based on what we know about the enemy's capability. They do modeling and simulation also. They have some sophisticated tools that they use. Test and evaluation. They support the fleet out there. If there's a system out there on a ship, something's gone wrong with it, they get out there and fix it, if you will. And they provide ship operational guidance. What speeds, what heading. If you're confronting an enemy, what speed or heading should you take to minimize your signatures, if you will. So they do all of that. Here's a couple of their facilities. This is an anechoic. I don't know if you've seen this at Corrado. It's an anechoic flow facility. So you're passing air over this model. This is a submarine sail to look at the flow noise across that structure, and then modify the shape, whatever, to get that flow noise down. That's at the West Bethesda site. This is also at the West Bethesda site. This is the magnetic spheres lab where they put in a submarine model, and measure the magnetic signature of it. I failed to mention that. It's another signature that you want to keep down on both surface ships and submarines, if you will. That's a major facility at the West Bethesda site. Okay, shifting to Philadelphia. Philadelphia focuses primarily on machinery systems. They do some work in submarine sales, heavily into all of the networking and sensing for machinery systems. And they do some research. And they've done, the folks at the Philadelphia site, when they were at the Annapolis laboratory, they were formerly located in Annapolis, Maryland, at a Navy laboratory right across the river from the Naval Academy. That's where, over years, they did work to quiet the machinery on submarine systems so that our submarines are the quietest in the world. And so those folks now reside up at the ones that didn't retire reside at the Philadelphia site. This shows you some of their facilities. This is, I don't know if you could see it, but this is a full-scale version of the power plant on the Arleigh class destroyer, if you will. So they're evaluating various types of new systems, like different motors, if you will, but they actually have a gas turbine, LM2500, that's part of that power plant, to evaluate new control systems for the power plant, and they actually do some training in that system, with that system. They bring the sailors in and do some training. They get involved with also some of the auxiliary systems, both air conditioning, refrigeration, various pumping systems like fire mains, if you will, on the ship, and life support systems on submarines. This shows some of the other areas and facilities. Again, I mentioned the networking and sensors and the data analysis that goes with all that sensor information. They have a bank control room that actually operates that power plant. They also have a very quiet room. This is fairly recent, an anechoically quiet room, so that they could measure the noise associated with flow and piping. Okay, you go in that room, it's so quiet you can't go to sleep. It's too quiet. I mean, you could hear yourself think in that room. It's just so quiet. They also have a aircraft carrier elevator to look at weapons handling on ships, if you will. They do some work. Well, here they're doing some work with a new door design for a deck house. And I think, although it's hard to see, this is a facility for doing work with antenna systems on a submarine. There'll be somebody here from Philadelphia on the 13th to tell you more detail about the kinds of things they do. I think that finishes the Carteret division, so where are we? Oh, okay, we'll go through this quick. I'm getting you out of here before 8 o'clock. Okay, Panama City. I never worked at Panama City, but I know some of the people there. There's the LCAC. Can you read that? Landing craft air cushion. So it rides on the cushion of air. So it could ride on a cushion of air in the sea. It could do it on land. So it takes the Marines from the ship all the way up onto the beachhead. Okay. They are responsible for the in-service engineering of that craft. The actual design of the craft was done in a team made up of industry. Used to be Bell Aero Systems down in Mississippi, and the Carteret division that were involved in the early concept design of the LCACs. And there are lots of the LCACs out there. So what's their mission? They're, again, like the other labs, RDT&E and in-service engineering for mine warfare systems, for mines. So we want to counter their mines, we want to look at the effectiveness of our mines. They also support the special warfare community, their systems. I'll show you an example of that. They're, I believe, a center of excellence for diving and life support systems, and they also support the Marine Corps, their amphibious expeditionary maneuver, and other missions associated with coastal or littoral regions. They apply, this is what they say, their vision is they apply innovative science and technology solutions to meet the challenges for littoral access and coastal defense. Here's how they're organized very briefly. I'm going to just talk about there are 3 technical departments. Actually, the kinds of things that go on in the 3 technical departments. Again, they're located in Panama City. So the science and technology departments, again, these are just examples, if you will. They get into the sensor areas, different development of different types of sensors, and then also the signal processing and information fusion that would go along with those sensors to increase the speed, reduce false alarms, and operate over long periods of time in a marine environment. They get heavily involved in experimentation, particularly with the fleet. The fleet does experiments, several each year, and they get involved with those. Here, this is the high-speed vehicle that the Navy leased from the Australians, primarily for the purpose of transporting Marines and equipment in a very effective manner. It's an aluminum ship. They found out there were problems. These are commercial designs that the Australians made. So they weren't for military application. When you put it into a military application, take it out in the open ocean, put the weight on it that you have to do to support the things you're moving, and you get things like cracking in the aluminum, if you will. They're also involved in unmanned systems. A few examples shown here, and you'll see some others in the subsequent view graph. Both the autonomy, they were part of the team that was working on that system of unmanned systems I mentioned earlier. Control of those unmanned systems, as well as automated launch and recovery of those systems. Mine warfare. A couple examples, mine warfare. They're interested not only in detecting mines, but neutralizing mines. This shows you a surface ship countermeasures approach. This is called the RNS vehicle, remote mine system, if you will. So it's launched from this ship, operates close to the surface, and can be used to detect mines. This is an air-delivered system. I believe it's the Oasis system that's actually, it's pulled by a helicopter, okay, for detection and neutralization of mines. And so they're heavy into this kind of stuff. They're also involved with the module development for the littoral combatant ship. Remember I mentioned that went out with that ship and actually gets put over the side to go do the mine warfare mission. Here's an example of one of the systems they're involved with a special warfare community. This is, they call it the Mark 8, Mod 0. It's a SEAL delivery system. So this is deployed from the dry deck shelter on top of a submarine, which transports SEALs to wherever they need to go, if you will, and hopefully in a covert manner. Do other types of development to support the special warfare folks, doing hydrographic reconnaissance, so the SEALs or other special warfare folks know what's out there in the area that they're operating. Again, they are center, or they call themselves Center of Expertise for all military diving. They have they're dedicated to supporting the Navy's experimental diving unit, okay, and all of the life support systems that they evaluate associated with that unit. And they also have the Department of Defense Primary Diving School at the Panama City facility. Okay, there's the expeditionary warfare area that they support, primarily for Marine Corps, doing in-service engineering of the LCAC. It shows the LCAC in operation. Again, this comes out of the whale deck of the LPD-17 class, the San Antonio class amphibious ship that I showed you. I didn't realize that but they also developed a system to pre-detonate IEDs for the Marine Corps, to protect the personnel and the vehicles that they travel in. Okay, so shifting away from technical stuff, a little bit about career planning. So these are the defined competency areas within the Naval Sea Systems Commands. You can see they're quite varied. We've been focusing on program management. Remember, the program executive officers managing those acquisition programs. and research and systems engineering. So those are clearly two competencies you might be interested in, but there are others, okay, just to make you aware of that. Here's how they define the career levels within each of those competency domains. When you first start, you're at the entry level. So you're carrying out assignments using basic principles, concepts, methodology you learned in college, basically. And you work yourself up to the journeyman level. You've been there a while, you've gained some experience, and the journeyman level is the full performance level, typically, for engineering. I guess that would also apply to those other competency domains. I'm most familiar with engineering. But there's a level above that you could go to called the expert, where you're the one that advises the Navy in a particular area. We have what we call senior scientists. I'm giving you an example from the Carter Division for propulsors. So there's an expert or senior scientist for propulsors. There's one for acoustics. And there are three others, which I think there's one for chaos theory. I can't remember the others. Anyway, those are examples of, so most of the people work at this level, but you can get up to this level. And there's also, not shown here, there's a management career ladder too that you could go up. And I guess that would come under the program management career ladder. These probably still apply to a certain degree if you're outside of the engineering or technical career ladder. There are 5 components of planning your career. At least the Navy's interested in these 5 components for you. Your professional development, your personal development, so balancing work versus your own personal life, that's important to do. Leadership, whether you're going to stick out and take on a leadership position. There are certain certifications or qualifications that the Navy might want you to have for a particular job that you're in. And then, of course, performance, measuring your progress. So those are the components of career planning. These are some programs for students. Now, you should have a copy of the handout. Do they, Beth? Where did Beth go? You don't know. It's not in this handout. It's a separate handout. Do you have it?
This slide here?
No. For each one of these, there's a handout. Sorry, there's a handout that covers these in more detail. I'll try to just go through them briefly, if you will. If I could find the piece of paper that goes with them, yeah. So the CAP program is basically for high school students. So I'm not sure that applies to any of you. As a matter of fact, I'm quite sure it doesn't apply to any of you. MRAP program is a I can't do much without my glasses. These I haven't committed to memory. We just recently inserted these into the brief, and I think it's a very important addition to the brief. But it's basically 10 weeks of work during the summer doing research at one of the Navy laboratories. You have to be a junior, senior, graduate student, or going into your junior year, if you will. You have to be enrolled at a university, which you are, if you will. The stipends is what you get paid. I don't know if you're interested in that, but I'll pass that on anyway. It's like, for undergraduates, like almost $7,700 for 10 weeks. Not too bad. Unless you're living in you have to go to Washington, where it's costs you to live. Probably more than that. And for graduate students, it's a little bit over $10,000. There's a website to go to if you want more information on that. The STEP program is a temporary employment program for student hires. You do not achieve tuition support with this. And I suggest you look at the handout on this one. I'm not going to say much more about that. The Student Career Experience Program, SCEP, that I believe replaced, that one replaced the old co-op program. Do you remember the old co-op program? Any of you familiar? I did co-op. when I was at the University of Detroit. You worked for 3 months, you went to work for, you went to school for 3 months. They was on a quarter system and so on. You got paid while you worked. Well, with the Navy had that program, when you were doing your work assignment, you were gaining credits to your retirement account. So if you worked, 3 years or 4 years under the co-op program, that's probably unreal. It's probably 2 or 3 years. That would have counted to your retirement. Your retirement, when you started full employment, you're probably in your 4th year. Okay? I don't think that applies under this new program. But they do. Let's see. It's flexible work schedule. Could be full-time or part-time. You got to take at least half academic or vocational or technical courses. There is an opportunity for non-U.S. citizens, but there are certain requirements that go along with that. Okay, the SMART program. Most of you are familiar with the SMART program? No? This is a scholarship program where you could get, where they'll pay you to get an undergraduate degree, a master's degree, or a doctorate degree. Has to be in the STEM field, the fields of STEM, science, technology, engineering, and mathematics, if you will. The annual stipend for this is $25,000 to $41,000, depending upon your prior education experience. Of course, they pay for your tuition. There's an allowance for books and all that kind of stuff. Very good program, but very competitive. Very competitive, as you can imagine. There's a workforce recruitment program for people that have disabilities, if you will. That's in your handout also. It's co-sponsored by the Department of Labor and the U.S. Department of Defense. And the last program is the Naval Acquisition Internship Program. This is after you're hired by the Navy. If you qualify for it, you're applying, you get selected for this program. You go on 1, 2, maybe 3 tours of different parts of the Navy within the Naval Sea Systems Command to get experience, and then you get the opportunity, I believe, to choose. Don't quote me on that. Based on what you've learned, where you'd like to work. It's very helpful in accelerating your progress up the career ladder, having that on your resume. So those are 5 programs. They all 6, 7. Sorry, they're all in this other handout. They all have websites, I believe, you could go to get more information. People you can contact to get more information. But several opportunities there. Encourage you to explore. Oh, this shows you how those programs are broken out with high school, undergraduate, graduate, and career. Okay, so I think this is the last slide, except I think in your handout you have some acronyms. I'm not going over those. I just included those for information. So if you go to work for the Navy, don't rest in your specialty, diversify and challenge yourself. There are lots of opportunities to challenge yourself, if you will. A good example of diversifying, remember I mentioned that Innovation Center. That's clearly an opportunity to diversify, but there are many other opportunities. Get to know the people in other departments across the enterprise, the organization you're working in, and beyond. Become active in professional societies. Important. ASNE is the American Society of Naval Engineers. SNAME is the Society for Naval Architecture and Marine Engineering, and I think you're familiar with ASME. Take advantage of paid educational benefits. So even if you don't get into one of these programs we just went over, there are opportunities to take coursework for a graduate degree. The Navy will pay for that. You'll probably have to do that on your own time in the evening. If the course is off into the day, you'll have to make up the time. But they'll pay for the tuition if it's relevant to the work you're doing. So you can't go out and take a bookkeeping course if you're doing acoustic silencing work, obviously. Be sponsor-oriented and customer-oriented. I always say you ought to not satisfy the customer, but delight the customer. Give the customer more than he or she expects, if you will. I think you're a winner all the time if you're able to do that. You're not always able to do that. Be proactive. That goes up to the first one, and seek challenging assignments. There are some formal mentorship programs. They're not always available, but if they're not, suggestion is that you try to do it informally. You get to know the people you're working with, some of the senior people, the journeyman types. You know, use them as a mentor. I think that's helpful for your career. I talked about this later. Don't get frustrated with the bureaucracy. I mean, you could try to change it, and some of us have, and some have been successful, but don't let it get in the way. You're doing a good job, your technical job. Just put it behind you. Do an individual development plan. I think that's required now. It wasn't when I was working, but it's very important you do that. Okay? And the last thing is your job is important. It's important to the nation as well as yourself. So I think that completes all I have to say. We're 3 minutes before 8 o'clock. I promised you that. And those are the acronyms. So any questions at this point?
Hello? Yeah, what exactly is this individual development plan? Is it just pretty much just mapping out your career?
This is something that you would put together with your supervisor, mapping out the kinds of things you're working on, the kinds of additional education you might want to take, the types of maybe different assignments, that kind of thing. So it's what you ought to be doing to help your career, help you advance in your career. Okay? Any other questions? Well, thank you for your attentiveness. I appreciate your interest. I hope this has been helpful. And I wish you good luck in your choices for a career. Again, we need you smart people in the Navy, and that's all I have.
Thank you.
You're welcome.